Okay, welcome back. What you see on the screen now is where we left off last time. As I promised last time, I wanted to talk about this idea of a two-tailed test. What the heck is that? Um, okay, let's think about here's where I wish I had a really good whiteboard in front of us. Let's think about our null hypothesis. Our null hypothesis, when we're testing for means, is that the mean for one group is equal to the mean for another group. And remember that we don't exactly expect the means to be exactly the same. And the reason we're doing the t-test is to tell us whether any differences that there could be between the means, whether that's due just to sampling error or random error, or whether it's due to something systematic, that men and women really are different, or African Americans really are different than Caucasians, and so forth. Now, so that, remember, that p-value is a probability, right? We're not proving anything in statistical tests. We just say it's unlikely. When the p is less than 0.05, we're saying it's unlikely that the difference that we see between these two groups is due just to chance. That null hypothesis just says that they're not equal. And when we have an alternative hypothesis that says, the null hypothesis says that they are equal, The alternative hypothesis says that they are not equal. But it doesn't say which one is larger. It just says that they're not equal. And that's called a non-directional alternative hypothesis. We don't know in what direction the means are different. So we don't know if freshmen are higher in their alcohol use than seniors. We just, within our non-directional alternative hypothesis, we're just saying that they're different. Now, if we really have an informed hypothesis, we might say, as I did a video or so ago, that I thought that seniors would be higher in the alcohol consumption simply because they're older and they can legally buy alcohol. So there I have what's called a directional hypothesis. My alternative hypothesis is directional, and then I'm saying I think that one group is going to be higher. That's very different than saying they're just going to be different. When I say they're just going to be different, that's this two-tailed hypothesis down here. That's this two-tailed null hypothesis. Now let me show you a little bit more about this. Like you, I went out and I can Google just like you can, and I Googled one-tailed versus two-tailed hypothesis, and I ended up with this nice little website out here at Missouri State. Okay, now take a deep breath here. This is what we call a theoretical probability distribution, or as they call a sampling distribution. This sampling distribution we use, remember in our hypothesis testing, we compute a test statistic, we compare it to this probability distribution, and if the probability of that test statistic is less than 0.05, then we reject the null hypothesis. We've said that at least 100 times in this class. So, but here's 101. We compute a test statistic. If the test statistic is associated with a probability of less than 0.05, we reject the null hypothesis. But what do I mean by associated with a probability of less than 0.05? That's the point here. So let's pretend that this is a t-value, like this 2.28 and this negative 2.28. The probability of this 2.28 happening is really the area under this curve. Now that requires calculus to compute, and we don't worry about that because the computer does it for us. And the probability of this negative 2.28 or less is the area under this curve, is right here, this little chicken McNugget as I like to call it. Now, if our p-value is 0.05, we have to divide that in half, and we have to put 0.025 here and 0.025 here. Because if we have a non-directional alternative hypothesis. If we're just saying we think they're different, then we have to cover both sides of the distribution. If our alternative hypothesis is that the two groups are not equal in their mean, then we're using what's called a two-tailed test. Now, the problem with that is you can see that well, let's go to the one-tailed test, and I think you'll see the difference. If we have a one-tailed test, if we're sticking our neck out and we're saying, oh, I think that the seniors are going to be higher in their alcohol consumption, then I benefit because I get to take this 0.025 probability and add it to this 0.025 probability and end up with all of my 0.05 here. And that means I can have that there's a smaller t-value associated with that probability. Let me just say that again. When we have a one-tailed test, that is, when we have a directional hypothesis, we get to pile all of our probability out on one side of the distribution. That means that we don't require as large of a t-value in this case in order to achieve that 0.05. See how this is a two-tailed test and there's 0.025 p probability here and 0.025 probability here. By that I mean that the area under the curve is equal to 0.025 and the area under this curve is 0.025. The area under the whole curve is 100%, but there's 2.5% here, 2.5% there. That requires a larger t-value, either higher or lower. If I'm just going to say the seniors are going to show higher alcohol consumption, I get to put all of my probability here, and that lets me have a lower t-value. That lower t-value literally sets the bar lower. It's like a high jump. We can set the bar lower and we don't have to show as strong a difference between the two groups because we have a more powerful test. Now, had I said that the seniors are going to be lower, then I would be working down here with a single-tailed test here. Let me just go back to that t-test and show you. Here we're talking about a two-tailed test. Now, if we have a directional hypothesis, like I had here for the risky behavior, we actually get to divide this p-value here by 2. So we actually end up with a p-value of whatever 0.176 is, which is like 0.08 something. So we're getting closer to our 0.05. So we have a more powerful test when we are smart enough and we know enough about human behavior in order to put together a directional alternative hypothesis. Okay, I want you to go back and review this tape and let it sink in before we go on.